Okay, class, we are going to go over graphing quadratic functions today. So you should have the lecture notes provided, and if you don't, you should print them out from Moodle. So quadratic functions, as you know, are functions that are degree 2, and they are going to have the characteristics where it opens up if a is bigger than 0 and down if a is less than 0. So a is the coefficient of the x squared number. And then we also have the graph is wider if that a is essentially a fraction between 0 and 1, and narrower, it is narrow if a is bigger than 1, like if it's a 2 or a 3, because you have this sort of shrink and stretch going on. The x-coordinate of the vertex is the minus b over 2a, so that is something that you do need to memorize. As well as the axis of symmetry is the equation x equals minus b over 2a. It's the vertical line, so it has that equation x equals. And the axis of symmetry, as you remember, is the vertical line going through the vertex. Okay, so the first example, we're going to graph this function in standard form. So we have the a, b, and c, and since a is bigger than 0, we know that it's an upward-facing parabola, because our a value here is upward. It's positive, so it's upward facing. So we can find the vertex using minus b over 2a. So when we plug that in, minus b over 2a, we get an x-coordinate of 2. We plug that in, and we get the y-coordinate of negative 2. So we can go ahead and plot that point. So please follow along and plot the point to negative 2 on your graph. Okay, so now we plotted that, what we can do next is we can draw in the axis of symmetry, and the axis of symmetry is the vertical line that goes through the vertex, and the equation is x equals 2. So then we can go ahead and find the x-intercepts. So to find the x-intercepts, we set our equation set equal to 0, and we factor it. If it doesn't factor, you can complete the square or use the quadratic formula. This is example, it does factor. You should use the box method if you need. You can pull out the GCF of 2 and then factor. That would be easier. And since you have 2 factors set equal to 0, you can use the zero product property and find the two x-intercepts, which we can now plot at 1 and 3. And you do know that the axis of symmetry is the line of symmetry for the parabola, so the x-intercepts should be equally spaced on either side of the axis of symmetry. And then we're going to plot at least one more point. So if I plug in x equals 0 into my equation, I get out 6. So I do have another point 0, 6, and I can use symmetry to plot another point over here, so that I have a total of 5 points. Okay, so once you have your 5 points, then you can connect it and have this rounded curve. So we do have a parabola with arrows on the end, and it is U-shape, not V-shape. Okay, so now we can go ahead and graph another problem, and we'll talk about the different forms that we have. So we can graph a quadratic function in Algebra 2 it was called vertex form, and our book is calling this standard form, when we have forever and ever always called the previous problem standard form when it was ax squared plus bx plus c. So I'm going to use the words vertex form and standard form interchangeably, but just know that this is what your book is referring it to. It's essentially when we've completed the square, like when we did the conics. We know that the vertex is h, k with the opposite value of h. Okay. So our axis of symmetry is still whatever the h is, x equals h. Intercept form is when it's already factored so that you know that your two intercepts are your p and your q. And the axis of symmetry is the midpoint, halfway between those two intercepts. You can just find the average, take p and q, add them up, and divide by 2, and that would be the equation for your axis of symmetry, the midpoint. Okay, and still you have this a value out front, so it tells you the same rules of opening up or down. Okay, so this is in vertex form, or as your textbook calls it, standard form. So graphing this, we know that we can just read off the vertex, which is why it's called vertex form. So we have our h is minus 3 because it's the opposite sign, and our k is a positive 4. So this is where our vertex is. So we can go ahead and plot our vertex. And furthermore, since we do have our a value is a negative number, we know that it is a downward facing parabola with our vertex at minus 3, 4. So when we go ahead and plot that, we can imagine it going downward. So we just need to plot extra points. Okay, so we have the axis of symmetry. We know it's going to be symmetric. We're going to solve for the x-intercepts. We're always going to need to find the x-intercepts if they exist. So to find the x-intercepts, we just set our function equal to 0, and then we just solve using the rules for all of the solving that we've been doing this semester. So we don't get a whole number. We do get an irrational number, which we can find the approximate values on a calculator. So once we have those, we can plot our two x-intercepts, and you do see that your x-intercepts are symmetric across the axis of symmetry. Okay, so now we have 3 points. We need a total of 5 points. We're going to plot the value of x equals 1, and then when we plug in 1 into our function, we get a value of negative 4 out. Then we can use symmetries. Since it's 4 units over here, we can go 4 spaces to the left to find the 5th point at negative 7, negative 4. And then we can just go ahead and draw in the parabola, and you do see that it is downward facing, which it should have been. We have our vertex, our axis of symmetry, the two x-intercepts. Okay. So this next function is a quadratic in intercept form because it comes pre-factored. When it comes pre-factored, we can just read off the intercepts. The x-intercepts are minus 2 and 4. So we know those, and we also know that it's a downward facing parabola. Okay, so when we plot our two x-intercepts at negative 2 and 4, we know that the axis of symmetry is the midpoint, so you can just use your fingers to count inward to your axis of symmetry at x equals 1, or you can just average them. Negative 2 plus 4 divided by 2. So you take the two x-intercepts, sum them up, divide it by 2, and you get x equals 1 for your axis of symmetry. And it does have to be symmetric. So we have 2 points. We need 5 points. We know that the vertex is on the axis of symmetry. That's by definition. So when we plug in x equals 1, we should be able to find the y-coordinate for the vertex. So we can just plug in 1 into our original function to get the y-coordinate is 9. So we know that the vertex is at 1, 9. So we plot that point. So now we have 3 points. We need a total of 5. So you pick any other point. Plugging in x equals 0 is always a nice point to plug in. So you plug in 0 into your equation, and you get positive 8 out. And then you use symmetry to get 2, 8. And then you just draw your parabola. It should be U-shaped with arrows, and confirm, yep, it is downward facing, as we said it was originally. Okay, so that is all. I hope you have a wonderful evening tonight, and I will see you in class.